Hi, I am SB sir and I will teach you today the kinetics of enzymatic reaction. What do we mean by kinetics? Kinetics is the study of enzymes when the enzymatic velocity, kinetic means the velocity of an enzymatic reaction gets altered with substrate concentration. And this is very important. Why? Because the velocity is directly proportional to substrate concentration, and this changes after a certain substrate concentration is reached. Means the velocity is lowered with substrate concentration, and this lowering of velocity with increase in substrate concentration is actually a kinetic study. So what do we mean by kinetic study is by if we draw a plot where we plot substrate concentration with velocity. If in the y-axis we record velocity and in the x-axis we record substrate concentration, then with increase in substrate concentration the velocity changes. With increase in substrate concentration the velocity changes. And how the velocity changes? The velocity changes according to a rectangular hyperbola. This is the shape of a rectangular hyperbola, and this is the reflection of how an enzymatic reaction is actually followed. And this is the Vmax, the velocity maximum of the reaction. Now, why do this velocity gets altered with substrate concentration? Say at this substrate concentration, the velocity is high. At this substrate concentration the velocity is higher, but the change of velocity, see the change of velocity with this difference, I have made the difference is the same. The difference in substrate concentration is the same. Here the difference of the substrate concentration is same, but velocity here, this is bigger than this change of velocity. So this is the velocity has increased in a lower fraction, but here the velocity has increased with the same increase in substrate concentration. The velocity has increased more than this portion of the curve. So this has an explanation. What is the explanation? With more substrate concentration, this is the initial substrate concentration. There are very large, compared to the enzymatic molecules, the substrate concentration is much more. So enzymes get progressively saturated. The substrate binds to the enzyme, and the enzymes get progressively saturated with the substrate, and so the velocity change is actually lowered. So if we say that the velocity increase is much steeper here, the velocity change is now follows a much gentle gradient here, because the substrates now saturate the enzyme, and at a certain point of time the saturation is such that the enzymatic reaction increases, the velocity of the enzymatic reactions stops to increase, and it gets in a steady state value. This is the steady value, the highest steady state value, where with increase in substrate concentration, if we increase the substrate concentration here we see the substrate concentration has increased, but the velocity has not changed, and we say the reaction has gone to Vmax, the velocity maximum. The reaction has progressed to its maximum velocity with the increase in substrate concentration. So this is the study of kinetics of enzymatic reaction, and this kinetics of enzymatic reaction is given by Michaelis Menten equation. Now what is Michaelis Menten equation? We will see that Michaelis Menten equation is a plot of velocity of an enzymatic reaction with there are parameters which are present in the Michaelis Menten equation. Velocity is equal to Vmax into the molar concentration of the substrate by Km plus S, the molar concentration of substrate. Now there is a new term Km, there is a new term velocity. The velocity is given by the velocity maximum multiplied by the substrate concentration by Km plus S. Now this is called Michaelis Menten equation, and we need to memorize it. Velocity of an enzymatic reaction at any point of time here, the velocity if we want to know the velocity of the enzymatic reaction, we have to refer to Michaelis Menten equation, and the Michaelis Menten equation says velocity at any point of enzymatic reaction is equal to Vmax into S by Km plus S. So you need to memorize it before going into the next steps of calculating the importance, knowing the significance of Michaelis Menten equation, knowing what are the other parameters that can be derived from this Michaelis Menten equation, knowing about an enzymatic kinetics into much deeper ways, knowing the inhibitions, the different types of inhibitions of an enzymatic reaction. So the first thing here is you need to memorize it. Velocity of an enzymatic reaction is given by Vmax into S by Km plus S. So we will progress into the next step of the step, and we will see that how this is, how the Michaelis Menten equation governs. Say I draw two curves here, one here, and one here, two more extra curves. So if this was the original curve of original rectangular hyperbola, this is also an original, this is also a rectangular hyperbola, this is also another curve. So here the Vmax is the same. Because here we plotted velocity with substrate concentration, here Vmax is the same. Half of Vmax is also this line, half of Vmax. If this is the maximum velocity, this is half of maximum velocity. The maximum half of maximum velocity is here, but the half of maximum velocity in this three types of kinetics, in these two kinetic reactions, the half of maximum velocity is reached at different substrate concentration. So this is a lower substrate concentration, and this is a higher substrate concentration compared to this one. Compared to this one, the original curve, say, and at lower substrate concentration, half of maximum velocity is reached. At higher substrate concentration, half of maximum velocity is reached, but the maximum velocity is the same for all these three curves, or all these three kinetic reactions. Now this velocity at which half of maximum, this velocity we say the half of maximum velocity, the substrate concentration at which half of maximum velocity is reached is called the Km of the reaction. The Km, why now if we here in this curve, if we say that what is Km, Km is half of maximum velocity. The substrate concentration at which half of maximum velocity is reached. This is the definition of Km. So here, if we just put the value of Km as half of maximum velocity, if we replace the velocity value at Vmax by 2, say this velocity is equal to Vmax S by Km plus S. So Vmax and Vmax gets cancelled. So 2S equal to Km plus S. And then what is Km? Km is 2S minus S. Is equal to S. So Km is the substrate concentration at which half of maximum velocity is attained. So by replacing the velocity of the reaction by Vmax by 2, just from this figure, the Vmax by 2 is here, we get a value of Km which is actually a substrate concentration value, a concentration in molar concentration of a substrate. Km, the value of Km is in molar concentration of a substrate, it is a substrate concentration value, and we get the expression of Km as it is a substrate concentration value. Now I have written the Michaelis Menten equation, and I need to tell you a few more details about this importance of this Michaelis Menten equation. The importance of Michaelis Menten equation is that it gives us much more valuable information about the enzyme kinetics. Now I will explain how it does so. The enzymatic reaction depends on the substrate concentration that I have told you in this previous curve. that with increase in substrate concentration, in x-axis, we have seen that the velocity changes. The velocity changes because this is the plot of velocity. The velocity changes. Now we need to know certain details about this change in velocity. How does the enzyme react to, how does the substrate changes the velocity of an enzymatic reaction. Now, if we see that at higher concentrations of substrate, we have seen that at half of the maximum velocity, the substrate concentration that we know is that is the Km. At half of maximum velocity, the substrate concentration is the Km of the reaction. Now, what is we need to know about these things a little bit more. Suppose I take a substrate concentration in a test tube which is much more than Km, So, this lower value, the denominator of this reaction, Km plus S, we can write it because the substrate concentration is much more than Km at very high substrate concentration. Km is just this substrate concentration. I take a substrate concentration here in say a much higher substrate concentration. At much higher substrate concentration, I take a substrate concentration which is much higher than the value of Km. Then how the Michaelis Menten equation changes. Then we can see that we can then ignore this Km, and we see that this we can ignore this Km because this is a very insignificant value, the Km, the substrate concentration, compared to this. So the reaction changes as V equal to Vmax into S by S, and the substrate concentration cancels out. So the velocity of this enzymatic reaction becomes a constant. Vmax is a constant for any enzyme. So the velocity of an enzymatic reaction gets constant means it is a zero order reaction. It's a zero order reaction. Now zero order reactions are reactions which does not depend on substrate concentration. So at higher substrate concentration, we can say that enzymatic reactions at very high substrate concentration does not depend on substrate concentration, and it follows zero order kinetics. Suppose we take a substrate concentration very low substrate concentration. Suppose we take substrate concentration here and the Km value is much higher than this. Then what we can see from this Michaelis Menten equation, if we then ignore then we can ignore this value, then we can ignore this substrate concentration value, then the equation changes as V equal to Vmax by Km, and we can ignore this substrate concentration value into S. Now this is a constant for an enzymatic reaction, so it depends on S. We cannot ignore the upper part, we cannot ignore the numerator, but we can ignore the denominator. So the Km plus S becomes Km. We can say it is the Km, but even if it is very low substrate concentration, the numerator is multiplied by Vmax. So we cannot ignore this numerator. So at very low substrate concentration, it depends on the constant into S. So the velocity depends on S, or the velocity is directly proportional to substrate concentration. And this is the first order reaction. This is a first order reaction because first order kinetics, because why? Because the velocity now depends on the substrate concentration. It depends on a parameter. It depends on a single parameter of substrate concentration. Here it was not depending on substrate concentration, but here it depends on substrate concentration, and so we say that is the first order kinetics. So here we see that in condition 1, that is the substrate concentration is much higher than Km, the enzymatic reaction follows a zero order reaction, and the velocity does not depend on substrate concentration. At higher substrate concentration, it will be following a maximum velocity, and it will not depend, it will reach the maximum velocity and it will not depend on substrate concentration further. The velocity will be at maximum velocity. So it follows a zero order kinetics. And in condition 2, that is Km, the value of Km is much greater than substrate concentration. The value of Km is much greater than substrate concentration, means at very low substrate concentrations here at very low substrate concentrations, while the value of Km is much bigger. The value of Km is much bigger. The equation changes like this, that Vmax by Km into S, that is the velocity is directly proportional, velocity is directly proportional to substrate concentration, and it obeys a first order reaction because it is dependent on substrate concentration, and we say it is a first order kinetics, and here the velocity is directly dependent. So with little increase in substrate concentration, the velocity changes radically. With little increase in substrate concentration, the velocity increases radically. Let us now go into a altogether different topic, a little bit of coordinate geometry, and I will later explain you why did I go through this revision, so that you can correlate that with the enzymes. Let me tell you that the equation of a straight line is y equal to mx plus c. Why is it an equation of a straight line? Because it gives 2 points, at x equal to 0 and y equal to 0. This is y positive, y negative. So at x equal to 0, y equal to mx plus c, At x equal to 0, y is equal to c. So x0 yc is a positive point. So it will fall x, because it has no value of x, so it will fall along the y axis, So it will fall along the y axis, and it is a positive value. So say this is the point and positive value. So this is x0 yc. At y equal to 0, is in the x axis. The point will lie in the x axis. At y equal to 0, mx plus c equal to 0, or x equal to minus c by m. C goes here and m goes below. So x equal to minus c by m. So at y equal to 0, x is a negative value. X is minus c by m. So negative value falls in this part of the x axis. So this point is minus c by m, the x value, and the y value is 0. So this point is minus c by m and 0, and this point is 0 and c. Let us now go to a new Michaelis Menten equation. Now this is the Michaelis Menten equation that I told you in the previous part of this class. V equal to Vmax S by Km plus S. Now if I just draw a reciprocal of this equation, so reciprocal of this equation is 1 by V equal to Km plus S by Vmax plus S, Vmax into S. So the equation is now, if I separate these two parts, then Km by Vmax into 1 by S, I can write it like this, plus S by Vmax S. If I write it like this, the S goes away. So this 1 by V is actually a changeable parameter. Velocity changes with substrate concentration changes. With this change in substrate concentration, the velocity changes, and this part of the equation is actually the parameters Km and Vmax, which are constant for an enzyme substrate couple, the Km and the Vmax. This is actually the variable portion, 1 by S. and this is 1 by Vmax. It has turned into 1 by Vmax, or it's also another constant. It more or less it follows the equation of a straight line as 1 by V. We can compare it to y equal to, this part is m, the slope of the curve, the slope of the line, the slope of this line, the slope of this line. I have just joined the 2 points, and I have drawn the line of the straight line that I described. The slope, whether it will be like this, whether it will be like this, whether it will be like this. These are the different slopes, and this is the slope. M is the slope into 1 by m. X is 1 by s plus c, and the c is 1 by Vmax. So here the c, instead of c, if I write 0 and 1 by Vmax and minus c by m, minus c by m, minus c by m as, what is m? M is Km by Vmax. This is m, and above c, what is c? 1 by Vmax. So 1 by Vmax, 1 by Vmax into Vmax goes above Vmax by Km, Km goes below. So minus c by m becomes, minus c by m becomes 1 Vmax, Vmax goes away, minus c by m becomes 1 by Km. So if I write it like this, this is 0, 1 by Vmax, and this is minus 1 by Km, comma 0, 0 because this part of here we have taken y x equal to, here we have to, this is y equal to 0, x equal to minus c by m. The value of x is minus c by m and y equal to 0. So this point and this point, I have drawn the straight line version and the Michaelis Menten counterpart. The Michaelis Menten counterpart is, this point is 0, 1 by Vmax, and this point is by minus Km 0. According to convention, we write the value of x first, then give a comma, and then write the value of the ordinate or the y axis, and it is 0. Here, according to x, the value of x is 0 because it lies 0, comma 1 by Vmax, the value of the ordinate. The Michaelis Menten equation was V equal to Vmax S by Km plus S, and from this equation we have just reciprocated it in both the sides of this is equal to. We have reciprocated it and we have given it 1 by V equal to Km plus S by Vmax S by Vmax S, and cancelled out, and then we have compared it with the values of a straight line y equal to m into x, x is 1 by s, 1 by s, this is the value of x, and this is the value of c, the constant 1 by Vmax, the x cancels out. So y equal to mx plus c, that we have just told you. Now why did we do this? This is actually a linear transformation. We transformed this rectangular hyperbolic equation into a linear equation. We now get analogy with this linear equation. This is the equation of a straight line. This is actually a transformation of Michaelis hyperbolic kinetics to linear transformation. Linear transformation by this line, this double reciprocal plot. This is why it is called as double reciprocal, because we have reciprocated both the values in these two sides, reciprocated it by, we have written it 1 by V, and just here also the upper and the numerator and the numerator and the denominator got reciprocated. So it's double reciprocal plot. So we say it as double reciprocal plot, or linear transformation of Michaelis Menten equation, or this was done by Lineweaver-Burk, or the Lineweaver-Burk double reciprocal plot. Lineweaver-Burk plot. Lineweaver-Burk plot, or the double reciprocal plot, or the linear transformation of Michaelis Menten equation. Linear transformation of Michaelis Menten equation. MM equation. And now Michaelis is like, this is the y-axis, this is the x-axis, and it is now in the form of a straight line, where this straight line cuts the y-axis. The value of x is 0 and the value of y is 1 by Vmax, and here the value of x is minus c by m, if you can remember, minus c by m, because y is 0, x equal to c goes here, minus c by m, minus c by m, and so minus c by m is here. What is minus c? Minus c by m, minus c by m is equal to, what is c? C is 1 by Vmax, 1 by Vmax, and m is what? Km by Vmax, Km by Vmax. So m, Km by Vmax multiplied, it goes above Vmax by Km, and minus c by m becomes, to Vmax cancels out, minus 1 by Km. So here the minus c by m is minus 1 by Km, Km 0. The value of y is 0. So here we have transformed the Michaelis Menten equation from an hyperbolic form. The hyperbolic form was this. The hyperbolic form was this, with velocity here and subset concentration here. The hyperbolic form, this hyperbolic form is being transformed to a linear form, to a linear straight line form by this double reciprocation mechanism, the Lineweaver-Burk double reciprocal plot. So we have transformed the rectangular hyperbola to a linear form. The Michaelis Menten equations, linear form. 1 by V is equal to Km by Vmax into 1 by S plus 1 by Vmax. So this is the linear form of Michaelis Menten equation.